Hello again. In this video I want to talk about how we use Agile Requirements Designer to test graphical user interfaces, or GUIs as most people call them. GUIs have always posed a problem for testers because of the complexity that they present. And the validation dominates our testing in many ways. And although the validation often happens in the GUI, more often it's in the back end as well. How we model GUI applications is an important test design choice. So what I'm going to talk about is GUIs in general and how pervasive they are. When we use ARD to model a GUI, we have to think about the user experience, but we have to exclude it from scope, if you like, from the model. I then want to sort of talk about how we do model and test GUIs using ARD, and then discuss whether we should model the functionality, the processing, or we should model the data, and give some hints on that. Then I'll do a demonstration, and the summary will be quite extensive to discuss some of the issues to do with testing GUIs in general. Now, GUIs are everywhere. They appeared more than 30 years ago, and as soon as they arrived on the scene, they caused problems for testers because, first of all, GUIs include lots of elements that have functionality, be it large or small, behind them. So most data is captured in what might be called forms, either a web form or a form on a mobile device perhaps. We have buttons, menus, active links, drop-down lists, radio buttons, and so on. All these things have event handlers which deal with functionality dependent on what the developer wishes to achieve. Now, at one time GUIs were restricted to PCs or workstation applications. Now they're everywhere. They're on every smart device, your phone of course, but fridges, cars, printers, TVs, all these devices now have some form of smart UI, and it's a graphical one. Now, GUIs usually can be thought of as being a front end to some back end service. So the GUI captures data in some kind of form, and when the form is submitted, the data is processed by some server in the cloud or elsewhere on a network. So GUIs are usually accessed through browsers, but of course mobile applications and anything labeled smart actually has a similar kind of presentation, if you like. But some GUI applications don't need a back end. For example, Office products use local files. Some applications don't generate data, like a game of chess perhaps, or they're utilities that manage device configuration, so the data is in the registry of the system, if you like. So the way to think of GUIs in one way is as a client to a set of services at the back end. The back end might be the local file system. Now, one thing we need to be careful about is to say that we can't include a reference to the user experience in our models. So we have to exclude modeling the user experience. Of course, UX testing is mostly a human-centered activity. People have to do this by and large, even though there are some tools which can do some limited checking for us. So when we will model the functionality as seen by the user, but we have to treat the user experience separately. Now, in order to do this, we have to make kind of two assumptions, quite simply. And we should check that we're in a safe place when we do this. First, that actually someone is going to pick up the user experience testing independently of us. And second, that if the user experience triggers change to the application, well, our ambition is, or our hope is, that they'll have little effect on the underlying functionality of the GUI. So hopefully our models shouldn't change, even if the appearance of the GUI might. Now, in order to test a system comprehensively, we would tend to test the back-end services in isolation using some kind of driver perhaps, and then when we integrate the GUI, we test the GUI plus the back-end services as one. So service testing requires some kind of driver or dedicated service, of course, and we'll cover testing services, the modeling and testing in another video. We'll use the same approach as before. When we model, we'll model the functionality as seen by the user, and it includes the behavior of the back end. Now, most GUI testing centers around some kind of form which the user fills in to capture data, which is then submitted to some back-end service for validation and processing. So it doesn't matter to us in this respect whether the back end is a web server or an authentication server or some other kind of web service that calls other services perhaps elsewhere. We treat it as an integrated whole for the purpose of our modelling. Now, one way of looking at modelling a GUI looks at, if you like, the positive and the negative testing aspect. So negative testing being invalid data, we treat the invalid data rejected by the GUI and we model that as a subset of our model. The data that is valid and processed, by the back end in some way, we can model in a different way. Now we might combine these models into one large complex model, but we could also modularize it to split up the positive and the negative test, if you like. One way of doing this would be to put all the data validation checks and processing at the top of the model, and then follow that with the processing of positive data that makes it through, if you like, the first half of the model. Now another way would be to have a decision early in your model to split the valid data from the invalid data processing, and in that way you get a different appearance of the model, a different topology, if you like. Now splitting the model in this way can make the model easy to understand, but it could mean that the model diverges from the way the data is actually processed behind the scenes. So a question to raise is like, should we model the functionality, the processing, or should we model the data? It's tempting to create models that reflect the way the system under test actually processes data, so we might talk to the programmers and say, tell us how you created the software, and we create models that replicate their code. Now the alternative would be to reverse engineer the processing from our experience, so we simply look at the system as it exists and infer the behaviours behind the GUI from what we see as validated data, error messages, and the processing that we believe should happen. But ultimately we need to test the system, validate the entered data correctly, and process it correctly. If we model the functionality, there's a possibility we make the same mistaken assumptions as developers. If they advise us what the software should do, we inherit their assumptions as well as the design decisions as well. So the question arises, well, if we use the developers as our main source, are we independent? Are we giving an independent test anymore? If we attempt to model the functionality as described by the developers, we might actually become bogged down in creating extremely complicated models, simulating every line of code in the server-based functionality perhaps. So there's a challenge to us as to how we approach this idea of modelling. Is there a general rule for deciding whether we model the functionality or the data? If we're creating a model before the system is built, and we're creating the model to describe the functionality or the requirements from users, we have to model the functionality quite clearly, and that functionality in the model will be evolved into code and the application under test. But with a GUI that exists already, when we take that on, we have to, if you like, reverse engineer the functionality to interpret what we see on the screen and the behaviours we experience when we explore the software. We have to reverse engineer to generate the model from what we learn. So it usually makes more sense to model the data in this respect. Now there's a kind of a generic kind of process that I'll suggest you might find useful when you're modelling a GUI form. When you see the form for the first time, the first thing to try is to submit the form with no data. So don't enter any data, don't select any drop-downs or checkboxes or anything like that. Just click submit and see what happens. What should happen is the mandatory data fields that aren't automatically filled by the program will be flagged as error messages. So what you'll see is things like data fields that have to have a non-blank value, drop-downs that must be selected, radio buttons, checkboxes that must be clicked, and so on. So with this you have your first cut view of the validation of the GUI. After that, select the drop-downs and checkboxes and radio buttons and complete the fields that trigger elements on the web page to appear or disappear. And by that I mean sometimes when you select a value in a drop-down, some fields just beneath it appear and are required elements to fill in to complete the form. So identify the fields that actually cause these elements to appear or disappear. Beyond that, for each field, we're looking for validation rules. So a drop-down gives you no choice at all except what's available. So all should be valid. But with text boxes, values like dates and numbers, think through what validation rules exist behind those fields. Finally, you need to consult your sources of knowledge, the spec, users, developers, to complete your analysis, to fill in the gaps in your knowledge. Now, for the purpose of the demonstration, I'm going to use a live, real insurance company website to look for a quotation for motor insurance. And the form is quite complex in that it collects a lot of data. And fortunately, it has like 5 sections, each of which gathers data about your car, yourself, your address, discounts, and there's a final section on assumptions and conditions, if you like. We'll split the model into a master model and sub-processes for these 5 sections of the form. But actually, when we go a bit deeper, we'll see that actually we need 3 more sub-processes to deal with other questions to do with accidents you've had in the past, additional drivers on your policy, and motoring offences if you've got any. So we actually have to create 9 models in all. This is a large form collecting a lot of data, and the production of the quotation by the back end follows some extremely complex logic. Now, this back end process is testable, or should be testable, independently. And I talked earlier on about testing the back end separately from the system as a whole. So we won't look in any detail at the complex logic behind the processing itself. So I'm just opening the page for the motor insurance calculation. And you can see as it loads there are 5 sections just dimmed there, and what it will do is it will open up the first section with the data fields ready to go. So as I scroll to the first section, you can see a series of elements in the first section with this next button, which basically validates the data in that section and takes you into the next section without stopping you proceeding with partial or incomplete data. So let's just walk through the fields one by one. So the first field is whether you're insuring a car or a van or pickup truck, I guess. If I click on van or pickup, it actually takes me to another screen because it's a different policy process. So I'm going to stick with car. So that field doesn't need to be entered if you like. I can enter my registration number, annual mileage, estimated car value, there's a date when I purchased it, it may be that I plan to purchase it, and then there's a date when I want the cover to start. If I just click next just to see what happens, okay, so what's happened is it's scrolled me down to section 2, but I know it doesn't like most of what I've left on the screen, so it requires a car registration and it asks me to find the car, annual mileage, value, and so on. All these fields with the orange background clearly are required fields. So in my model, I know I will have to create checks for each one of these red bounded fields. If I just go through the optional fields, I can just select some of these, and as I choose a value that's valid, it resets the background to be white. If I choose not yet bought, okay, that seems to work. I can put in a date, I think. I can put in a date, and that seems to work okay, and it unchecks the not yet bought field. And dates I can select. Okay, so that looks okay when I select a start date for the cover. So you can see that it's pretty straightforward so far. So far so good. Let's look at the About You fields now. If I scroll down to the bottom of that section and the next button here, this is obviously much more involved. Let's just click next and see what happens. So again, it's scrolled me down to the next section, your address, but I want to look at the section 2, About You. So I have a title, sure, that's fairly routine. First name is mandatory, last name is mandatory, date of birth, mandatory. Marital status, okay, that seems okay. What is your main job? I think I have to type something in here and it'll do a search. So I have to make a choice of one of these elements in here. And there are certain occupations are excluded. Okay, so that makes sense. So let's say I'm a civil engineer, for example. Type of license, full or provisional, yeah. How long have you held your license? Okay, just a straightforward number of years. Since when have you lived in the UK? I can say since birth, or I can choose make myself very old. Okay, that seems okay. Accidents. Now this is interesting. If I say no to this, that goes green and it takes me on to the next section. If I say yes, it asks me the nature of the accident. So okay, I need to be careful about that. So that's a check box, that's a radio button, if you like, that reveals or hides this claim section. I can actually add another claim as well. So I could do this to my heart's content. So I have one claim here. This is a second claim, so I could have had multiple accidents and insurance claims. Okay, I can also delete claims as well. The next one is, have you had any motoring offences, including convictions, endorsements and so on? If I say no, it turns green, moves me on to the next field. If I say yes, it tells me these are the kind of motoring offences that it recognised. If I choose other, it turns out actually I have to put in more details, and again there's a searchable list here, so I've no idea what some of these are, but so these are the different crimes I can commit in my car. There's a date, a number of penalty points on my licence, and maybe I got a driving ban which could go to 60 months, good heavens. So you can see there that I can add multiple claims, but also multiple convictions. So if I really am a lousy driver and a bit of a liability, I can fill this to my heart's content. Okay, so that's interesting. The next one is whether I pay annually or monthly. So that looks okay. Do I want to add another driver? So it could be insurance for myself alone, or I could add another driver. If I say no, okay, I can move on to the next section. If I say yes, it asks me for the relationship of the driver, contact details, date of birth, yes, what kind of license, how long they held it. So it's a similar set of questions as before. Have they had any accidents? Yes. Oh, and actually they could then go into the accidents and claims section. So there's also convictions, so I can check that, and I can add convictions as well. So to my heart's content, I can keep on adding more complexity to this submission. Let's go to your address and see what comes up here. If I click next, it'll do the validation for this section. So again, I see lots of orange. So postcode, it's looking for an address. So if I say F as an example, it gives me a choice of addresses. So choose that one, and there's an address chosen. Please tell us if you own your own home. Yes or no. Nothing complicated there. Are there other cars and vans in the household? So I might say yes, I've got 2 cars. Add an email address, yeah. Contact phone. What month is your home insurance due for renewal? So again, it's a piece of marketing information I think they want, because they're going to sell me, I think, house insurance as well. So that's that section. Discounts is basically about, do I qualify for any reduction in the insurance premium? So do I have a no claim discount? How many years have I not claimed? Am I under 26? Yes or no? So here we have the question, do you or anyone living at your address have any other existing line car or van policies? So I can say yes or no. If I say yes, no, nothing much happens. Are you a named driver on another policy? No, does nothing. Yes, it asks me who the policyholder is, initials, date of birth, postcode, and I confirm that they've been consulted that I'm doing this. Last one, do you or anyone you live with have an existing policy? Again, I can say yes or no. That doesn't involve anything else. So I can say next to that and then hopefully go to the last section. So yes, okay. So the last section, there's obviously some terms and conditions. I confirm the above statements are true. I guess it will reject my choice if I don't tick that. Have I had an insurance product cancelled or declared void? If I say no, presumably that's what they expect. Yes, nothing much happens, so I'll say no. Finally, do I want to get SMS messages? Yes, no. Nothing much there. Then I have the reCAPTCHA kind of code here, which I might want to put in, and then continue. So if I just click continue, I get the whole form validated. So some of the data I've put in already, just random kind of values to see what happens. But it looks like I can manage the modeling of this in kind of 5 modules, for the 5 sub-modules, sub-processes if you like, with one master. But it's interesting that where I want to add other drivers, or I have driving motor offence convictions, or I have accidents or claims, I know I'm going to create some sub-processes for those as well. So all in all, I'm going to have 9 processes. Okay, so here we are in ARD again, and this is the, if you like, the insurance quotation master process. And you can see the 5 orange subflows, each of which has like a valid path going top to bottom, and errors encountered during that sub-process all go to an errors endpoint. So if you like, all the input validation that fails, whereas the system rejects the data, will follow a path from the start point at the top through to the errors endpoint on the right. And the only way that the procedure can finish completely is that all the data is correctly validated on the form, and then it's processed in this kind of purple process here. So in effect, I've simplified the whole process and separated the invalid checks and outcomes to the right in the errors endpoint, and all the valid data processing all passes through what I've labelled here the process valid data box towards the bottom. Now I'm not going to, in this video, explore the valid processing rules or how the system behaves and deals with correct data. My suggestion is that that would be done using a driver or dedicated test tool to drive tests through the web services or backend or whatever it is that does the calculations. And this is a common way of working in this kind of application, because the backend is used in probably other applications to do the calculation of premium values and so on. So it's normally tested as an independent unit or engine, if you like, whether it's a web service or a piece of code dedicated to doing the calculation. So I'm not going to explore that in any great detail here today, but assuming that you could model it in just the same way as we've seen before, and particularly with web services. So you could extend the model in that way, or have a completely separate model for testing the back-end process in isolation. One last thing to say is that you'll see this pattern in the sub-processes when I open them up. You'll see that I have this kind of valid path going from top to bottom, north to south if you like, and the error exit from the process somewhere on the right of the model, and where there's a loop, I tend to loop from the bottom through the left hand side of the model back to the top, and the start point again of the loop. Now let me just reduce the size of the page, and you can see on the left hand side I've got my ARD model, and on the right I've got the actual web page that we're looking at that I showed you a little bit earlier. So as we go through the sub-processes, I can show you how the elements in the sub-processes map to the fields on the screen in the GUI. So let's open up the GUI ensure sub your car. So this is the details of the car. So we'll open this model. So this is quite a straightforward model. There are 4 elements being checked, and you can see that there's a valid path from start to bottom, and the outcome is valid your car as a section in the form, and then there are 4 errors found. In fact, it doesn't quite map to the content of the screen. I'm not going to get into some of the details on the GUI, but I just want to show the principles, if you like. So that looks okay. So I have a valid outcome, valid your car, and an error outcome, and that basically is this box here. Let's look at the about you flow, which I'll open now. And this is obviously more substantial, so as I scroll down, I'll click next to show it. So the about you page has quite a few fields. Again, the model isn't a perfect representation. I've not gone into a couple of details on here, the links that exist, but let me just blow this up a little bit, and then you can see in a bit more detail. So the typical way this is done is I have say a job title here. Now if I look at the form itself, you can see that the job title is a drop down, and it's possible for me not to select it. So if I click next and scroll back up again, as you saw earlier, it validates that and says title is required, so I can't just leave it blank. Now it's typical of all the fields on here that if there is no selection made at all, then we get this error condition, you know, the kind of orangey brown background and the red border on the field. So I've implemented that in the model as a valid title is either true or false, and the false choice is basically no choice made, because it's impossible to choose anything outside what's in the drop-down list. Okay, so you'll see that pattern again and again, and you have this valid title, valid first name, valid last name, date of birth, marital status. So I've been kind of stupid in some respects in that I've just taken the validation as a true false. There's no variety in the outcomes there. And I've got one decision here, which is main job, which if I scroll down is this field here, and I need another outcome to add to the errors, so that's that. Now when I come to the type of license, it's interesting that you'll see I can choose full or provisional, and both of these links, if you can just see it on the model, go into the next element of the model. But if I don't choose a type of license, again I get none going to the error exit. Also with period of license, if I choose none, that goes to the error. In here, the period of license, I actually created a whole series of outcomes, so I can just, if I can just extend that, I think I can show you there are actually 9 outcomes from 0 years up to 9 or more. In fact, that's probably 10, isn't it? Okay, and they all go from period of license to lived in UK. What next? So now I have how long I've lived in the UK, and it could be since birth, or I have a valid date, or if I have an invalid date, or I don't make any selection. Again, that takes me to the errors exit point. And here I come across the accidents and claims sub-process. So in the form we have this whether you've had an accident, yes, no. If I say no, nothing much happens. I go to the next field. If I say yes, some new fields appear. So let's look at the sub-process I've created for this subsection of the form. Okay, so again we've got a start and valid claim at the end. It could be that I come into the this process and say I've made no claim, so that's the no answer to this question. If I don't select, I get an errors outcome. Otherwise I have the 4 fields, accidents, the claim type, the claim date, and then I get the choice of adding another claim. So I have a kind of a loop here to rotate through this whole claims addition process. And when I'm done, I fall through into the valid claim. So there are some claims. So when I come into the parent process, the About You page, I have 4 outcomes. I've got, let me just try and separate these out. I've got no claims, valid claims, which I won't move, and errors. So again, regardless of how many claims I make, how many times I go through this loop, I get valid claims eventually, no claims and errors. So that's the parent process, and it shows you how that's dealt with. Now the next one, the next section of the input form is motoring offences, and convictions, endorsements, and so on and so forth. If I say no, not much happens. If I say yes, then I'm invited to start creating these conviction types. So in here, let's open this form. I'll close that one. So here it's a bit more complicated, there's more going on. So I have the same question, have you got any convictions? No, I exit immediately. All the error outcomes go to the right hand side to the errors exit box. And then here we have the flow through these fields here. And it's complicated by the fact if I choose other, I have to then have an extra field which is to select a particular type of offence that needs to go on my application. So I'm not going to go into this in any great detail, but again, the checks are either a valid outcome for a selection on the screen, an invalid input for, say, a date or one of the other values, or I didn't select it at all, in which case I'd get an error. So quite often the errors basically include ignoring the field and putting an invalid value in. So again, there are 3 outcomes. No convictions, I don't add any convictions to my application. There's the errors outcome, and then there's the convictions outcome. So if I go back to About You, I have the 3 outcomes: no convictions, convictions, errors, which goes back to the errors exit box. Payment cycle, I have a choice, monthly or annually. And then I have a third sub-process in here, so let's look at this one. Now this sub-process relates to the additional drivers. So again, if I say no to additional drivers, nothing much happens. If I say yes, I'm invited to add the details. So in additional drivers, again, I've got quite a complicated flow here. And as usual, I've got the, if I scale that up a bit, no additional drivers, so I come straight out of this sub-process. All the errors go to the errors endpoint here, and I have in the middle of all this a sub-process here to do with accidents or claims. In fact, this is the same sub-process that I used earlier on for the main driver, i.e. myself, when I'm applying for the insurance. So again, that sub-process has its no claims, valid claims not selected. Now in fact, we can also add offences and convictions for the additional drivers too. I've not added that. I mean, that would have been prudent to add that as part of the model, but I didn't want to get too dragged down in all the detail, because I think the point is proved that you can use subprocess to provide the modularization and the hierarchy of models that allow you to abstract away repetitive features of the system. So that's additional drivers. I'll close that one. So here we are back with the about you subprocess, and the outcome of the about you is the valid about you. So the valid outcome basically is all the fields are added without error. So if we close that, and I won't save it. So we're back at the top level process now. We've just done the about you subprocess. Let's look at the your address and see how that looks. So again, there's quite a complicated process here, but if we look at the address fields, there's a lookup of a postcode, which I showed you before, owning our own home, and if I look at the detail here, I can add numbers of cars, contact email. So these are all fairly simple inputs, with again the errors on the right catching all the invalid inputs trapped by the validation. There's a kind of a decision here which bypasses the house number and flat number if I have used the postcode lookup. So that's your address. So that's that one. Let's look at discounts. So here again there's a whole series of fields. If I click next on the GUI, you can see all the discount fields. So this is the discounts page, and you can see there's a whole series of fields and decisions made within this section of the form. Again, as always, errors on the right and the valid discounts as an outcome towards the bottom. The last subprocess is the what's called assumptions. I'll open that. And as I scroll down, there are some checkboxes here to say whether I have read the terms and conditions, have I had an insurance product cancelled or declared void by an insurer, and then I have the privacy questions to do with SMS and marketing and that kind of thing. So this is the final subprocess here in the master, and then if the process flow makes it through assumptions to process valid data, this purple box is where the action happens in terms of the back end performing the calculations. Let's pause for a moment and just look at how we define our coverage strategy for the insurance premium calculator. We've looked at the 5 sections of the form and created subprocesses for each, managed by a master process, if you like. Now, although we have these subprocesses, the features of the form itself can't be tested independently. It's all one big form, really. So if we use subprocesses in our models, when we perform the optimizations on parent models, the default process integration is stored paths. That is, the parent will look at the stored paths for all the subprocesses and take that as the source information to generate paths at the higher level. Now, let's take our strategy to be fairly simple and pragmatic. What I'm going to suggest is that for each subprocess, we'll choose an optimization that looks thorough enough to exercise that part of the form. We'll look at generating paths for all start and end points and store the paths for each subprocess. They will be reused by the optimization at the next higher level. Now, because most paths complete when an error is encountered, we'll attempt all paths, the optimization to start with. Now, if this turns out to be too cumbersome and too excessive, we'll use all edges instead. Now, part of the optimization is some processes have loops, and we'll just use one single iteration for the loops to cover those aspects of the sub-processes as well. Now, choosing all edges, actually in these models that I've shown you and the way we've constructed the models, all edges actually generates a similar number of paths to all pairs and all in-out edges. So all edges gives me some comfort that actually the model is completely covered in that every decision outcome is exercised somewhere. Okay, so here we are back at the master model for the insurance premium calculator, and I'm just going to go into the sub-processes and look at how the path optimization can work and how we store paths to have them available for reuse when we do an optimization at the highest level, at the master level if you like. So in here, if we go into Path Explorer, I'm going to choose all possible paths and see what comes up. And actually there are only 5 paths. In fact, there are 4 error conditions and 1 successful execution going towards the valid your car, as you can see. So I've saved those in a previous session. So that's good, I like that. Let's look at the next one, about you. So in here we have, as you can see, some sub-processes towards the end of the overall process. So I'm going to look at the sub-processes first. So let's just zoom in first. And this is accidents or claims. So we'll open this one. Here we can look at the Explorer. I'll look at all possible paths, but I also have one loop. So I'm going to set the loop iterations to 1. Look at all possible paths, and that gives us 8. So that seems reasonable. I think it's quite important we test this aspect of the functionality. You can see I've already saved those same 8 test cases in a previous session. So far so good, so let's close that one. So now let's look at the convictions sub-process. So again, a reasonably complicated path, and we have a loop. So we'll go into Path Explorer, look at all possible paths, loops as 1, and I'm getting 41 possible paths. Now that seems a little high to me for the nature of this feature of the GUI. So what I'm going to do is step back a little bit and look at all edges and see what that gives me. That gives me 10. That sounds more reasonable. There are certainly 7 decisions in there. So to have 10 paths, that should exercise all the edges, all the outcomes of each decision. So that gives me some comfort that it's the right level of coverage. And you can see this is what I did yesterday. So moving along, we have another sub-process in the About You sub-process. Additional drivers. So this is more complex again. So we'll go into Explorer. We'll try all possible paths. There is a loop. We'll set that to 1 and give it a go. So again, we're getting quite a lot of paths through this section of the system, 45 in this case. My gut feel is that's too many for me to be able to test, particularly when we combine it with other paths in the other sub-processes. So I think it's prudent to look at all edges instead. And that gives us 13 paths. So in fact, that's what I used yesterday as well. So 13 paths gives me some comfort. There are about 10 or 11 decisions. And again, as you will recognize that most outcomes tend to be the error outcome. So the paths tend to be fairly simple from top to bottom, going to the error or to have a successful outcome. So I'll close that one off. And that's the end of the sub-processes for About You. So with the About You sub-process, let's go into the optimizer and we'll choose all possible paths. There are no loops in this model, so let's just give that a go. It's telling me there's potentially over 1,000 paths, which is not workable, I'm sure. So I'm going to step back from that and do all edges. So this has come up with 20 paths through that sub-process. In fact, this sub-process is the most complex part of the GUI form itself. So I'm comfortable that 20 is probably a reasonable set of tests. Again, it's a gut feel. I can always add manual tests if I feel that it's not quite doing what I want. But 20 is what I expected to get yesterday. And I've used that as a standard. So I've stored the 20 paths. So we'll close that sub-process. So that's the most complex sub-process. Let's look at the others now briefly. And with address, we'll look at Path Explorer. We'll look at all possible paths, see what this generates. 28, that seems a bit high to me given the complexity of this model. I'll go to all edges. And that comes up with 12. And 12 is what I used yesterday. So 12 seems about right. There's about 10 or so decisions and 12 paths covering all the outcomes of each decision. Sounds safe enough to me. So I like that. So we'll close that model. Next we have the discounts. Okay, so we're going to Path Optimizer, look at all possible paths. That's generating 38. Again, feels too high to me to be practical. I'll look at all edges, and that's generated 12. So 12 is what I chose to use. And the last sub-process, assumptions. Fairly simple, this one. So we'll Path Explorer. We'll try all possible paths. Again, 26 seems far too high, so I'm going to step back, use all edges. 5. And 5 seems fair enough for a relatively simple model here. So there we have all the stored paths for the sub-processes and the lower sub-processes, and there are actually several levels in this particular model. So what I'm going to do now is look at the Path Explorer and the optimization for the master model, for the whole application, if you like. We'll try all possible paths, see what this generates, and that generates 50. Now 50 test cases is quite a lot, but as you've seen, it's quite a complex form, and there are about 40 or so input fields, each of which is validated. And we know that when we have an error for each of those fields, it takes us directly to an error condition which is picked up by the master process. So 40 of those test cases are the endpoint, if you like, for the errors. Now the remainder are valid outcomes where we actually make it to the end of the process with valid data. So I think actually 8 actually result in a valid processing of the data. So the negative tests, if you like, comprise around 80% of the test cases that so far I've looked at, and 8 or about 20% result in a successful completion of the process, and the back-end process would be dealing with valid data in this case. Now, is that enough tests for the back-end? Well, I think not. What we've actually done is we've focused very much on the validation processes and the successful paths through those validation processes to get to the end of the validation so that the back-end can take over. Now, I said earlier, and more than once, that the back end probably would be tested independently of the GUI. They'd be tested in combination, but the back end probably has many business rules which have to be applied to arrive at the calculation of the premium for the motor insurance in this example. So I'd expect possibly several hundred test cases of the back end. Now, we haven't clearly achieved that with this model, but I would argue that we would create a separate model for the back end, and we have then the choice of testing the back end independently, or we could include the model for the back end where I've got this processing of valid data, and then I have the complete model of the front end and the back end, and we can model the paths and generate the paths in a very sophisticated way using the tool. The example application we've shown you today is quite large, but it's not untypical of the kind of GUI forms that you see on e-commerce applications on the web or on mobile and so on. It's quite clear that using sub-processes to decompose a large complex GUI into smaller pieces helps a lot, partly to understand the complexity, but also to allow for the fact that some reusable components might be part of the GUI, and so you can cover yourself in that way and save yourself some time. Now, the GUI model I've shown you doesn't describe the behavior of the back end. If you like, when a GUI is presented to you, you don't see the functionality at the back end. You just have to infer how the input validation is performed, and maybe the back end processing, you'd have to research more deeply into the requirements or talk to developers or users to figure out what the business rules are. Now, in the example I've shown you in insurance, the premium calculator is almost certainly a reusable component that would be used in other applications within the insurance business. And it's so critical that it's almost certainly going to be very thoroughly tested using a driver or dedicated tool. Having said all that, the kind of calculations that these backends do, these calculations for insurance premiums, these are very complex calculations with many business rules, and I've seen through experience that they take hundreds of tests potentially to assure. Now, one of the problems with such calculations is the oracle of predicted behavior. It's very common to have to build a sophisticated Excel model, if you like, to generate expected results and act as your independent oracle to the system under test. Now, in the example I showed you, the complex form was broken up into 5 distinct sections in the GUI itself. So to take those sections and to implement sub-processes to model each of those sections was a very natural way to break up the complex model and to align it with the original system. Now, when it comes to coverage of the GUI model and the system under test, there's a broad strategy that I would recommend. Firstly, that you need to perform local optimizations on the sub-processes and store the paths. These then become reusable components of the higher level optimizations. Now, if there are gaps or if there are areas where you believe the testing is a bit light, certainly you can always create manual paths to fill in these gaps or particular areas of concern. There is no one-size-fits-all strategy for modelling GUI applications. I mean, every GUI application appears to be different. There's very little commonality between them. But I hope to have shown you that Agile Requirements Designer can make testing GUIs much more systematic.